Hello everyone. Actually, this video is in a response to a comment where I made a full Laplace transform video. Someone asked me how is it possible to intuitively think about or visualize the Laplace transform for a simple signal such as sine t. And it was a really interesting question, and so I decided to make this short video. So in this video, actually, we will see the difference between the Laplace transform and the Fourier transform. Or for a simple time domain signal, we will take simple sinusoidal signal x of t as sine t and see how Fourier transform and Laplace transform looks visually. So let's start with the definition of Fourier transform. We know that it's the integral of our time domain signal with an exponential minus j omega t dt. And similarly, we do have Laplace transform, which is again an integral but with an exponential complex signal e power minus st, where s is a complex number sigma plus j omega. And so if we apply the definition of Fourier and Laplace transform to our very simple signal, which is sine t, what we get is like, let's first see the Fourier transform. So the Fourier transform of sine t is like we get two impulses, each at 1 and minus 1 hertz. So if we had like sine 10t, then we would have two peaks at minus 10 and 10. So it's telling me the frequency content. Here sine t means it's 1 hertz. And similarly, if we apply the definition of Laplace transform to sine t, we get 1 over s square plus 1, where now s is a complex number. And so this is how Fourier transform would look like if I plot it on omega versus j omega, like it's two impulses. And if we try to plot the Laplace transform, where now s is a complex number, we have like a j omega axis and sigma axis. So it's a plane. And now if I want to plot f of s, it becomes a 3D plot, and you have two mountain-like structures. And if you take the cross section along the j omega or the cross section, then it's equivalent to our Fourier transform. I visualize Laplace transform as well as the Fourier transform for our simple sinusoidal signals where x of t is sine t. And please do check the full video where I have the history of Laplace transform and the history of Fourier series as well.